everyone, my name is Rano Delagil and the rest of Shatlah team members are Ghaida Al-Atiyya, Lanit Bayan, Shroq Al-Umari and Zahal Al-Haydan, supervised by Ms. Tahani Al-Mana. Thank you for this opportunity to let us introduce our project, Shatlah. That's what we're going to present. We all know the importance of a plant in improving the quality of our life by reducing pollutants in our environment, which lead to increase the caring by human and also by countries. As what the Crown Prince of Saudi Arabia Mohammed bin Salman Al Saud announced, the second biggest regional afforestation initiative, Green Saudi Initiative and the Green Middle East. This initiative will help the environment by reducing the pollution in air. That's importance, increasing the human awareness with the plant, especially the internal one, which purifying indoor air and absorb pollution. Hence, the idea of Shatlah application came to help plants owners. Problem: lack of content in Arabic community, the difficulty in recognizing various types of plants, difficulty in determining the suitable amount of irrigation. Shatlah is a smartphone application intended for Arabic-speaking user to help them take care of their indoor plants. The application uses artificial intelligence technology to identify the plant by recognizing the picture taken by user, then will display its Arabic name and how to care for it. The app also allows the user to save plant information and add watering reminders. It also provides general guides in common indoor plants. Shatlah provides an IoT-based alert system through the use of a sensor to measure the moisture level and another sensor to measure the temperature. When sensor detect inappropriate values, the user will be notified by turning on LED light and getting a notification based on the triggered case.
In work presented by Pravin and Aids provide an enhanced system for the plant's monitoring process by applying the Internet of Things. They have used the humidity sensors to find the water level, also temperature and light sensors to have the proper amount of them to grow the crop better. The information is transferred through the global system for mobile communication module so that the farmers can get an alert immediately about the data related to the factors that are affecting the growth. They also use the Raspberry and Arduino microcontroller boards in processing the information that's received from various sensors. On the other hand, a study shows a system called Genetic Plant Identifier, which identifies medicinal plants from feature extracted. The machine learning algorithms, for instance, the naive Bayes support vector machine, K-nearest neighbor, multi-layer perceptron, and logistic regression were provided with the optimized features as an input for identification. According to another study, the researchers developed a portable device capable of recognizing the plant by taking picture and describing it. They have used the scale invariant feature transform extraction to detect the plant's feature recognizing leaf vein and LCD screen for displaying correct plant classification based on SVM. The result shows that the accuracy was for 84.29%. The following table shows a detailed comparison for Shatlah application with similar applications. Our competitive advantage is that we utilized IoT. Shatlah system consists of two parts, software and hardware. The software part developed with Flutter using Dart programming language. We use the Flutter since it makes cross-platform app development possible without compromising on quality. The hardware part consists of Node MCU, temperature sensor, soil moisture, water sensor, LED light, and breadboard. As a back-end services, we utilized Google Firebase real-time database.
The main idea of Shatlah application was to recognize indoor plants to get guidelines on how to take care of them. The API that was used to perform this process is Plant ID Image Recognition API. Because their accuracy success rate in identification reached almost 90%. Also, the number of identifiable plants was 12,665. So, in the beginning, we made a connection between the API and Shatlah application by hosting the code in Google App Engine SDK and get an IP address that we using it during the HTTP requests to let the process of recognition become cloudly. After connecting them, the steps will become that when the user takes a picture of the plant or upload it from the album, we will send it in an HTTP post request to our backend image recognition API, which will recognize the plant and returns a JSON file. This file contained a lot of information about the plant in English, so we extract the plant's English name only. Then we send an HTTP GET request to get the extracted name and search for it in our dataset, which is stored in the database. that we get it from Nabatati, which contains about 110 indoor plants. When the English name that we extracted from the JSON file matched with the English name in dataset, we will get the rest of the information and generate a full description which is contain the Arabic name, irrigation, sunlight, and temperature information. Then display it to the user. For IoT implementation, we used Arduino to write the sensors code in C++ programming language and connect them to Firebase by using the host name and authentication password to store any improper value in the database that was obtained from the sensors. We also used Firebase Cloud Messaging, which is a service provided by Firebase. We wrote the code in Node.js that in case any field in the database has been created, write, delete, or update, there would be a trigger that sends a notification with the message we want by taking the device token from Flutter and write it in the Node JavaScript code. Clearly, first, the sensors begin to detect values from either the ambient temperature or the soil moisture, and when they obtain an improper value, a LED light will turn on based on these four cases. Red LED light indicates a too high temperature value, which is more than or equal to 31. Blue LED light indicates a too low temperature value, which is less than or equal to 14. Yellow LED light for dry soil, that is more than or equal to 42, and green LED light for wet soil, that is less than or equal to 29. These improper values are stored in the database. Node JavaScript will trigger an update in the database and then send a notification to the user by taking the device token from Flutter and adding it to the Node JavaScript code.
Unit testing is a software testing that tests each unit independently. It tries to find problems early and verify the functions to make sure all the components are error-free and function correctly before being integrated with the system. And this table shows the unit testing for our application. In addition, we performed user acceptance testing to let the users test and evaluate the functionalities of the application in the real world to make sure of the usability and to handle all the errors before releasing the application. We conducted it on 5 Arabic-speaking users who have an interest in indoor plants. We test the software functions. In other hands, for the hardware, we ask the user for set the sensors and test different cases. In the end, the user acceptance testing showed that the application functions worked successfully as expected. Besides, the user's overall feedback clarifies that the application is easy to use and it will help them to detect indoor plants and take care of them. Based on the received feedback, we made some enhancements in the user interfaces. As a future work, we will consider the remaining observations that will be helpful to improve the application.
In Shatlah interfaces, the user can take a picture of a plant, then a description of that plant will be displayed, and the user can press on a plus button, so the plant will be added to the user collection and the added date will be included in the description. Besides, in the user collection, the user can sort his plant by choosing either the added date or plant name, and the user can schedule a day and time for watering the selected plant, and a notification message will be received to remind the user to irrigate the plant. In addition, if the sensor detects inappropriate value, then a notification message will be sent based on the triggered case. In conclusion, Shatlah will encourage Arabic speakers to own indoor plants by facilitating the process of identifying the type of a plant and the way to care of it. In addition, indoor plants can enhance people mood, reduce their stress, and boost their overall health. As a future work, we intend to cover outdoor plants and expand the feature through diagnosing plant disease and toxicity by image recognition of the plant problem. And we aim to handle the sensor notification to let it including the plant name. Finally, we are working to add a platform to share and discuss topics about plants. In the end, we hope that you like Shatlah application and let it be a part of your life.